I will begin by talking about some common configuration issues. While wireless networks are a huge convenience to users, they do introduce a new set of troubleshooting issues into the network. Not only do the standard issues that crop up in a wired network need to be considered, the added layer of complexity that adding a wireless access point brings to the table will also need to be considered. When wireless networking is brought into the mix, a very solid troubleshooting methodology becomes just that much more critical. Now on to the actual configuration issues. First up is the Service Set Identifier configuration, or the SSID configuration. When this is an issue, the major symptom is that the user is unable to connect to the wireless network, and the probable cause is an SSID mismatch. The corrective measure is to check that the SSIDs match exactly. Remember, they are case sensitive. Then there is encryption configurations. It has the same symptom as the SSID misconfiguration. The user is unable to connect to the wireless network. Probable cause is an encryption type mismatch or incorrect security key. The possible corrective measure is to check the encryption settings on the wireless access point and on the device to make sure they are the same. Another configuration issue that can cause problems is an incorrect channel or overlapping wireless channels. The symptom is that the user is unable to connect or the wireless network has very poor performance. The probable cause is either incorrect channels or the overlapping channels is causing the signal-to-noise ratio to be reduced. That's the SNR. The possible corrective measure include adjusting the LWAPP settings and device settings so that they're using the same channel. Hint, there are only 3 available non-overlapping channels on the 2.4 gigahertz radio frequency. Then there are incompatibilities. And the symptom is, again, the user is not able to connect to the wireless network. The probable cause is you have an 802.11a device being used in an environment in which it won't work, as in you're using 802.11g or n. Or there is a frequency mismatch between the wireless access point and the devices. The possible corrective measure is to make sure you're using equipment with compatible wireless standards. Untested updates can also cause a configuration issue. The symptom again is the user is unable to connect or there is poor performance. The probable cause is a conflict between the update and other configuration settings or the wireless network settings. The possible corrective measure is to roll back the system to the prior configuration. Here's another hint. It is a best practice to make a backup copy of a system before installing any updates. Let's move on to other wireless issues. Troubleshooting networks requires a combination of art and science. Some of the best tools in your arsenal will be patience and strategic thinking. Network issues can express themselves in a multitude of ways. One of the best things that you, as a technician, can do is to see if you can recreate the problem. An issue that can be recreated can usually be resolved easily. Also remember that the users you are dealing with are the reason that you have a paycheck. Treat them as you would like to be treated, even if it is the 10th time that you've reminded Bob that his username and password are case sensitive. Interference is a common issue on wireless networks. The symptoms include slow performance and/or intermittent drops. The probable causes can include overlapping channels, walls, or other equipment that operates in the same frequencies. Some possible corrective measures include changing the RF channel or frequency or adjusting the wireless access point placement. Then there's poor signal strength. The symptoms include slow performance and/or intermittent drops, especially towards the end of your wireless network coverage area. Probable causes include low RF power settings, antenna type, and/or the placement of the access point. Possible corrective measures include changing the RF power setting, as in increasing it, or adjusting the antenna and/or LWAPP placement. There is a caution here. Increasing your radio frequency power or adjusting the equipment placement may cause the signal to go where it was not intended to go. So if you do either of those, you need to check and make sure that you're not putting your signal where you don't want it to be. Bandwidth or device saturation can also become an issue. The symptoms include slow performance and/or intermittent drops. The probable cause is that there are too many users or applications for the available bandwidth. Possible corrective measures include increasing the number of wireless access points and/or changing to a wireless standard with more throughput. The wrong antenna type may also become an issue. The symptoms include low or no signal in an area, or signal in an area where it is not supposed to be. The probable cause is the wrong antenna type for the coverage. The corrective measure would be to change to an antenna type to suit the required coverage. Then there is signal bounce. The symptom is poor performance in unexpected locations or an unexpected wireless network signal in an area that was not intended to be covered. The probable cause is the RF signal bouncing off of a hard object. The possible corrective measure would be to adjust the wireless access point placement. Going to begin by talking about wireless environmental factors. When planning and setting up a wireless network, quite often environmental factors that may impact the wireless network are disregarded. It is easy to get distracted by all the moving pieces of the wireless network, as in the SSID configuration, encryption, and which standards to use. Dealing with these often leads to overlooking factors in the environment that may impact the quality of the planned network. To get the most out of a wireless network, these factors need to be taken into consideration as they can have a major impact on the overall quality and performance of the installed network. We don't think about it very often, but building materials can influence wireless networks. A wireless network works by sending and receiving radio frequency waves across a given area. Anything that can interrupt the signal or change the path of the waves can create a problem in the network. This is called signal bounce. The signal may return to the wireless access point out of phase, leading to poor performance or dropped packets. Alternatively, the signal may end up being bounced into areas where coverage was not planned, leading to a security issue or an interference issue with other wireless networks. Some building materials of concern include concrete walls, metal studs, and window films, particularly window tinting with a metallic content. When evaluating environmental factors, it is important to consider more than just the building materials. All hard surfaces have the potential to create an out-of-phase or bounced signal, including office furnishings and file cabinets. Using a wireless analyzer and wireless survey tools during the planning stage of a wireless network will lead to better placement of the wireless equipment, which ultimately leads to a better performing network. Let's move on to some wireless standard related factors. First up is wireless standard compatibility. Not all of the 802.11 standards are compatible with each other. This is partially due to the RF frequencies that are used, and with the most common frequencies being the 2.4 GHz or the 5 GHz radio frequency band. The problem with compatibility can also be because of the type of modulation that is employed. Modulation is the encoding of information to be placed on a carrier wave, and it's employed to put the signal on the network. The most common forms of modulation are orthogonal frequency division multiplexing, OFDM, and direct sequence spread spectrum, or DSSS. So let's look at a compatibility list for 802.11. 802.11a is not compatible with most other standards. 802.11b is compatible with 802.11g and N. 802.11g is compatible with .11b and .11n. 802.11n is compatible with 802.11b, G, and AC. 802.11ac is compatible with 802.11n. So let's talk about the wireless standards. 802.11b uses the 2.4 GHz RF band and DSSS as its form of modulation. It offers up to 11 megabits per second networking with a maximum indoor range of 115 feet and a maximum outdoor range of 460 feet. 802.11a uses the 5 GHz RF band and OFDM as its method of modulation. .11a offers up to 54 megabits per second networking with a maximum indoor range of 115 feet and a maximum outdoor range of 390 feet. Then there's 802.11g. It uses the 2.4 GHz RF band and it can use both OFDM and DSSS as its methods of modulation. .11g offers up to 54 megabits per second networking with a maximum indoor range of 125 feet and a maximum outdoor range of 460 feet. Then we have 802.11n. It can use both the 2.4 and the 5 GHz radio frequency bands with OFDM as its method of modulation. 802.11n can offer up to 600 megabits per second networking with a maximum indoor range of 230 feet and a maximum outdoor range of 820 feet. Finally, we have 802.11ac. It uses the 5 GHz radio frequency band with OFDM as its method of modulation. It's expected to offer up to 1 gigabits per second networking with a maximum indoor range of 115 feet. At this point in time, we do not have a maximum outdoor range as they're still working on establishing that.